Welcome to a January 9th LeetCode challenge, binary tree preorder traversal. Given the root of a binary tree, return the preorder traversal of its node's value. So we see a binary tree here given such as root is being 1, null, 2, 3. Therefore, we want to return the preorder traversal, meaning that we have to count the number as 1, 2, and 3 that way. So basically, it's the number we see in the first order that we approach first. There's a definition of preorder traversal, but ideally, you just count the number that you approach from the root node first. If it's empty, return empty. If it has one value, return one value. The number of nodes in the tree is ranging between 0 to 100, and the value of the node is between -100 to 100. Okay. So this is a classic preorder traversal function. So there is typically generally two ways to approach it. I might just do both. So the first one is using depth first search. So let's actually do a depth first search to demonstrate that. We want to create a private function called answer or output. List, and this is going to be an integer, a list of integers, because this is the answer we're going to return, integers, and that's going to be called output, and it's going to be a new array list. And then we're going to create a private depth first search function, so it's gonna be a void, returning void, which basically the first search is gonna take in the node, the tree node. Node. If node is null, then just return. Else, so what we're going to do is basically recursively call depth first search and visit the root first, then the left subtree, then the right subtree. And we'll do that. We're going to get the answer. Then add the node value. We're going to take the depth first search of node.left, take depth first search of node.right. So this is a depth first search approach. So we have a depth first search function, and now we just simply call depth first search on DFS on the preorder traversal root, and then we want to return the answer in our solution class. So let's run this. Integer semicolons. Okay, great. Oh, call this an answer. Alright, submit. So basically, if you let n be number of nodes in the tree, then time complexity of this function would be big O of n, since we visit each node at least once and perform a constant amount of work on each node. Space complexity is also big O of n as well, because space is taken by the recursive stack call. Ideally, we're not using any additional space for the variables, but the recursion internally calls the stack call, which can take equivalent of the depth of the tree. But the depth of the tree be in most n if we have like a linear type of tree, or it could be skewed if the tree is skewed as well. So that would be worst case big of n. So this is depth first search approach. We can also do this using recursion as well, but I think this looks good for now. Have yourself a great day, guys.